Hey everyone, today we'll show how to move our character using forces rather than setting their velocity like most people do. This approach has lots of useful advantages. It feels more realistic, and it behaves far better with forces like gravity, friction, and other forces you might want to add to your game in the future. In these cases, setting the player's velocity just doesn't cut it. So let's begin. We start off right where we left the last time with our jump and double jump mechanics ready in our varying height script. First, a little heads up. If you've been following along, then you might notice a slight difference in the jump method, where instead of getting the ground layer mask every time we jump, we now do it one time and store it in a variable. Now for the movement. All we want is to apply a force on our character in the direction we press. So it appears all we need is to write an if statement that checks whether we press the move button, and if so, apply the force in that direction. Let's apply this in our code. First, we create a float variable to store the X input, and another one for the move force. We store the player movement X input in the variable using this line. Then all that's left is to apply our logic like so. Let's test this in Unity and see how it goes. Set the move force and hit play. As you can see, we have two problems. One, if we keep pressing the move button, then the force continues to apply and our player keeps accelerating. We want it to stop accelerating after reaching a certain velocity. Second, if we let go of the move key, our player keeps moving for a while until it stops. Let's fix both issues. For the first one, we'll need to set another condition before applying the force. To do that, we add another float variable for the maximum speed we wish our player to have, and then in the update if statement, we add a double AND to indicate we want another condition to be met. There we write rb.linearVelocity.magnitude is smaller than the max player speed. This will ensure that we apply a force only if the player's speed is below the maximum. Testing this in Unity reveals another issue. The player moves in a jittery manner. This is due to friction. Basically, when the player reaches the maximum velocity, we stop applying the force, and so the friction slows us down, then the force kicks back in because our velocity is smaller, and so forth. The best solution is to simply get rid of the friction. We do that by creating a new physics material 2D and setting the friction there to 0, like shown here. Then we go to the player's rigid body and drop it in the material bracket. This also solves the known issue of players sticking to walls, so we got 2 for the price of 1 there. Now to fix the second issue of the player not stopping when we stop pressing the move key. We have 2 ways of doing that. 1, increase the linear damping when we're not pressing the move key, or 2, simply setting the velocity to 0 when we want to stop. Choosing between these depends on your preferences. Setting the velocity will mean instant stop, which can feel more responsive, but it will mean that your character will not be affected by physics when you don't press the move button. Increasing the linear damping is more complex, but offers more flexibility in the long run. To set the velocity, we need to simply add an else condition, and in there write rb.linearVelocity equals 0. So that means if we're not pressing the move key, then set the velocity to 0. Here's how it looks in play mode. To use the linear damping solution, we'll simply change the linear velocity line to linear damping and set it to some value like, let's say 4. You can see how this feels later and change it to fit your vision. The only remaining thing is to add another line in the first nest to set the linear damping to 0 when we run. This is how it looks with linear damping applied. Notice that it only works when we don't let go of the move key mid-air. because if we do, we'll get weird fall behavior. Fixing this involves creating a logic that only applies linear damping when the player is grounded, which is a great example of why state machines are so useful, but that's a topic for another video. For now, we'll use in our project the simpler method of setting the velocity to 0. One important remark though, when applying forces, it is usually advised to do it in the fixed update and not in the regular update method, because the fixed update runs in fixed intervals and the update runs according to the frame rate. Running forces in the update method may cause people with different systems to run your game differently. Moving in the fixed update solves this issue. Lastly, I think it's appropriate to change the name of the class and the script to player movement script, as now it is more accurately representing its contents. When you change the name of a class and script, make sure to reattach them to the relevant objects. In our case, it is the player object. And that's it. Your player is ready to hit the road. Make sure not to miss the next part where we'll show how to create a moving platform and how to fix them when things go wrong. And trust me, they always do. Thank you all for watching. I hope you liked this video and found it helpful and inspiring. If you like this series so far, please show your support by liking and commenting your thoughts and ideas. It will really help me moving forward. Please consider subscribing if you like these kinds of videos, as I plan to keep on making them. Thank you all, and I'll see you in the next one. Cheers, guys.